All right, 4.5 on dilations. Learning target. I can dilate figures and identify scale factors. This is an important lesson, okay? There's a lot of little things you need to know about it, okay? What is a dilation? Dilation is a change in size, okay? The shape stays the same, okay? So the shape is going to be the same, it's just going to be changing the size. So an enlargement, okay, an enlargement is when the scale factor is bigger than 1, okay, so greater than 1. For example, 5 or 3.4, okay. Reduction is when the scale factor is smaller than 1, so it's actually between 0 and 1. For example, I can have 0.5 or a half. Okay, so basically what you're doing is you're taking the figure and you're making it larger or smaller. Okay, and the way you do that is you use a scale factor. Okay, so after a dilation, the corresponding angles, okay, this is very important. The corresponding angles of the pre-image and the image are congruent, okay? And the corresponding sides are proportional, okay? They're not congruent. So remember, when we're doing reflections, translations, and rotations, you get the same, right? The sides are congruent and the angles are congruent. But now when we do dilations, the angles are going to always be congruent, but the sides are not. The sides are proportional, okay? Dilations, they preserve, so we say that dilations preserve angle measure, okay, but do not preserve distances. Okay, so the only difference here is when you have a scale factor of 1. Okay, so if the scale factor is 1, then that the images are going to be congruent. So what is the scale factor? The scale factor is a ratio, okay, of image over pre-image. This is extremely important that you know this ratio, okay, and how to find it, okay, when you have a problem. Let's take a look. Here is the dilation picture, an enlargement, right, or a reduction, and then what is the scale factor. First thing you need to do, identify what's the pre-image and what's the image, right? The image is always the letters A, B, C, so this is pre-image, okay, and the A prime, B prime, C prime, that's the image. Okay, so I know now that I'm going from this one to this one, okay? So how do we find the scale factor? So remember up here, image over pre-image. So here, because I have a figure with some side lengths, I will take the side length AB. So here, scale factor equals AB over A prime, B prime, okay? So that is 6, right? AB is 6, A prime, B prime is 3. That means the scale factor is I mess up the order. So let's fix this right now. So the scale factor, okay? Remember, image over pre-image. I labeled here the image. So start with A prime, B prime, okay, over AB, because AB is the pre-image, okay? So that is going to be, okay, A prime, B prime is 3, and then AB is 6. So that means the scale factor is a half. Okay, so this triangle is a reduction by a scale factor of a half. Okay, so now I want you to notice one thing. Okay, that this, if I use the B prime C prime, right? So B prime C prime over BC. Okay, that is going to be 4 over 8, right? Which reduces also to a half, okay? So the scale factor is going to be consistent throughout the sides, okay, of the triangle. So if I had a number here for AC and A prime C prime, the scale factor when I did the ratio would have to be a half as well, okay? All right, so let's take a look at, so here, that means that I'm just gonna point it out, okay? That's the scale factor, is a half. And it is a reduction, right? The scale factor is between 0 and 1, so that means it's a reduction. Let's take a look at the next one. Here now, A prime, B prime, C prime is the larger one, so this is going to be the image. And this is the pre-image, okay? So it's getting larger, right? So this is an enlargement, okay? And then to find the scale factor, we do the same thing. Now, I want you to write something here that for you to remember, okay? Here, it's a triangle, so I have 3 sides, okay? So the ratios of the sides is equal to the scale factor. So here we have image over pre-image, so A prime, B prime over AB is going to be equal to B prime, C prime over BC, and A prime, C prime over AC. Okay, so remember this ratio, that the scale factor is the ratio of the sides. Okay, so now let's find the scale factor here. Scale factor, all I need to do is to do one of the ratios, right? Because I've been told that this is a dilation already, so I know. So here, image over pre-image, I can do 9 over 3, which equals to 3. Okay, scale factor for that one is 3. All right, now let's take a look at how the coordinate rule looks like. So x comma y maps to kx comma ky. This is k times x and then k times y. So where k is the scale factor. Okay, so if we have to dilate a figure on the coordinate plane, all we have to do is times the coordinate points by the scale factor. Let's take a look at what this looks like. Here I want to graph triangle ABC. Okay, I already graphed it right here. And its image after dilation with a scale factor of 2. Now it has a point in front of the 2. Disregard that, okay? That's supposed to be 2. Okay? So basically what I'm going to do is I'm going to take the points A, B, and C, okay? And I'm going to times by 2. Okay, so A prime becomes 2 times 2, 4, 2 times 1, 2. B prime becomes 2 times 4, 8, 2 times 1, 2. C prime becomes 2 times 4, 8, 2 times 1, negative 2, okay? Then I graph it, 4, 2, so 4, 2, A prime, 8, 2, B prime, 8, negative 2, C prime. Okay, and the dilation is always going to go away from the origin, right? Because we're doing the dilation about the origin, okay? So notice that if I draw lines through C, it goes through 3C prime, and then A and A prime are on the same line there, okay, as well. Okay, I just want to write it here. This is all times 2, okay, and that's how I get the image. All right, this one now, I'm gonna dilate by a scale factor of a third, so that means I'm going to multiply each of the coordinates by a third. So K, L, M, N. Okay, this is a good way of getting your work organized so that you don't get confused. Okay, now a third of -3, okay, that's -1. Okay, so K prime, -1, comma, and then you can think about this as also 6 times 1/3, right? So 6 times 1 is 6, divided by 3 gives me 2. Okay, so you can do it like this. 0 times anything is 0. 6 times a third, again, is going to be 2. 3 times a third, right? You do 3 times 1 is 3. 3 divided by 3 gives you 1. 1. And then for n prime, it's going to be the same as this one, but a negative. So -1, -1. So let's graph it and just see, okay, I didn't make a point here on the top one, but notice that the images are the same, right? The shape is the same. They are just a different size. -1, 1, 2, K prime, 0, 2, L prime, 1, 1, M prime, and then -1, -1, that's N prime. Okay? Notice that the figures are the same as well, right? This just fell on top of this because it goes through the origin. This is parallel to this one. This is parallel to that one. This one is parallel to that one, right? It's just the same shape there. Yes, and what we did here is we just times 1/3. We times every coordinate point by a third, and that's where we got the new points. All right, you have two problems to do here. One, you're using a scale factor of 4, so it's an enlargement. The other one is a scale factor of 0.4, so it's a reduction.